theorem of arithmetic. Prime number. If P is a natural number with only one factor, namely itself other than 1, then P is called a prime number. Composite number. If a natural number is a product of at least two primes, not necessarily distinct, it is called composite number. Composite number has at least three factors. Natural numbers can be divided into three classes. 1. 1 is the only factor of 1. 1 is called a unit also. 2. A number P greater than 1 and it has prime factor P and 1. 3. Composite numbers. Let us take one example. Example. Express 12,740 as a product of its prime factors. Solution. Factorize as shown in table. We have factorized 12,740 as 2 into 2 into 5 into 7 into 7 into 13 as a product of primes. That is, 12,740 is equal to 2 square into 5 into 7 square into 13 as a product of power of primes. Fundamental theorem of arithmetic. Every natural number greater than 1 can be factored uniquely as a product of primes apart from order of occurrence of primes. Example. Prove that any value of n for which 4 raised to n does not end with the digit 0. Solution is as follows. If the number 4 raised to n for any n were to end with digit 0, then it would be divisible by 5. Therefore, 5 divides 4 raised to n. Therefore, 4 raised to n is equal to 2 raised to 2n. The prime factorization of 4 raised to n would contain the prime 5. This is not possible because 4 raised to n is equal to 2 raised to 2n. So, only prime number in the factorization of 4 raised to n is 2. So, the uniqueness of the fundamental theorem of arithmetic 4 raised to n is not divisible by 5. Therefore, 4 raised to n is not divisible by 10. Therefore, there is no natural number n for which 4 raised to n ends with digit 0. Let's take prime factorization by fundamental theorem. A is equal to P1 raised to A1, P2 raised to A2, up to so on Pn raised to An, where P1, P2, up to Pn are prime factors of A and A1, A2, up to An belongs to n. And this expression is unique apart from the order of Pi. Suppose B is equal to Q1 raised to B1, Q2 raised to B2, up to Qm raised to Bm. Some Pi would be Q1, Q2, up to Qm. Here, Q1, Q2, up to Qm is a prime factors of B and B1, B2 up to Bm belongs to n. So, we can write P1 raised to A1, P2 raised to A2 up to Pk raised to Ak, where P1, P2 up to Pk is a prime factor of A or B and Ai belongs to n union 0. Bi belongs to n, union 0. A is equal to P1 raised to A1, P2 raised to A2, up to Pk raised to Ak, and B is equal to P1 raised to B1, P2 raised to B2, up to Pk raised to Bk, where every P1, P2 up to Pk is a prime factor of A and B. I is equal to 1, 2, 3 up to K, and Bi is equal to 1, 2, 3 up to K are non-negative integers. D is equal to GCD of AB is equal to P1 raised to C1, P2 raised to C2 up to Pk raised to Ck. M is equal to LCM of AB is equal to P1 raised to D1, P2 raised to D2 up to Pk raised to Dk, where Ci is equal to minimum AiBi and Di is equal to maximum of AiBi. Ai and Bi are minimum and maximum numbers respectively. I is equal to 1, 2, up to K. P1 raised to C1, P2 raised to C2, up to Pk raised to Ck divides P1 raised to A1, P2 raised to A2, up to Pk raised to Ak, and P1 raised to C1, P2 raised to C2, up to Pk raised to Ck divides P1 raised to B1, P2 raised to B2, up to Pk raised to Bk. Therefore, D divides A and D divides B. Moreover, if C divides A and C divides B, then C divides D. Therefore, D is equal to GCD of AB. Similarly, M is equal to LCM of AB and DM is equal to P1 raised to C1 plus D1, P2 raised to C2 plus D2 up to Pk raised to Ck plus Dk is equal to AB, because Ci plus Di is equal to minimum AiBi plus maximum AiBi is equal to Ai plus Bi. Therefore, LCM of AB into GCD of AB is equal to AB. Example: find GCD of 144, 610 by Euclid's algorithm and find LCM of 144, 610 by using AB is equal to GCD of AB into LCM of AB. Solution: here A is equal to 610 and B is equal to 144. Now, we should find GCD of 610 and 144 by Euclid's algorithm. Therefore, 610 is equal to 144 into 4 plus 34. 144 is equal to 34 into 4 plus 8. 34 is equal to 8 into 4 plus 2. 8 is equal to 4 into 2 plus 0. Therefore, GCD of 144, 610 is equal to last non-zero remainder is equal to 2. Therefore, GCD of 144, 610 is equal to 2. Now, AB is equal to GCD of AB into LCM of AB. Therefore, LCM of AB is equal to AB upon GCD of AB. Therefore, LCM of 144, 610 is equal to 144 into 610 upon 2 is equal to 144 into 305 is equal to 43,920. GCD and LCM of three integers. Suppose A belongs to n, B belongs to n, C belongs to n. If D belongs to n, then we get D divides A, D divides B, D divides C, and if D1 divides A, D1 divides B, D1 divides C, then D1 divides D. So, D is the greatest common divisor of A, B, C. We denoted it by D is equal to GCD of ABC. Suppose A is equal to P1 raised to A1, P2 raised to A2, up to Pk raised to Ak. B is equal to P1 raised to B1, P2 raised to B2, up to Pk raised to Bk. C is equal to P1 raised to C1, P2 raised to C2, up to Pk raised to Ck. Here, Pi is a prime factor of any one of A, B or C. Ai belongs to n union 0. Bi belongs to n union 0. Ci belongs to n union 0. I is equal to 1, 2, 3 up to k. So, GCD of ABC is equal to P1 raised to E1, P2 raised to E2 up to Pk raised to Ek. And LCM of ABC is equal to P1 raised to F1, P2 raised to F2 up to Pk raised to Fk. EI is equal to minimum of AI, BI, CI. Fi is equal to maximum of AI, BI, CI. ABC is equal to P1 raised to A1 plus B1 plus C1, P2 raised to A2 plus B2 plus C2, up to Pk raised to Ak plus Bk plus Ck. AI plus Bi plus Ci is equal to minimum of AI, Bi, Ci plus maximum of AI, Bi, Ci. So, GCD of ABC into LCM of ABC is not equal to ABC. GCD of ABC is equal to GCD of A, GCD of BC is equal to GCD of A, B, C is equal to GCD of B, GCD of AC. We can get integer x, y, z such that ax plus by plus cz is equal to GCD of ABC. Similarly, LCM of ABC is equal to LCM of into bracket LCM of ABC. Example: find GCD and LCM of 15, 21, 35. Solution: first we find a GCD of 15, 21, 35. Method 1. 15 is equal to 5 into 3. 21 is equal to 7 into 3. 35 is equal to 7 into 5. Therefore, GCD of 15, 21, 35 is equal to 7 raised to 0 into 5 raised to 0 into 3 raised to 0 is equal to 1. Method 2. First find GCD of 15, 21. 21 is equal to 15 into 1 plus 6 15 is equal to 6 into 2 plus 3. 6 is equal to 3 into 2 plus 0. GCD of 15, 21 is 3. Now GCD of 15, 21, 35 is equal to GCD of 15, 21, 35 is equal to GCD of 3, 35. 35 is equal to 3 into 11 plus 2. 11 is equal to 2 into 5 plus 1. 5 is equal to 1 into 5 plus 0. Therefore, GCD of 15, 21, 35 is equal to 1. Now, we find LCM of 15, 21, 35. 15 is equal to 5 into 3. 21 is equal to 7 into 3. 35 is equal to 7 into 5. LCM of 15, 21, 35 is equal to 5 into 3 into 7 is equal to 105.